Okay, and why we need Hadoop, and why we are using Hadoop. So these are the things we are going to discuss in Hadoop, and what is there in Hadoop. And we'll discuss Hadoop ecosystems, how will be Hadoop programming. So these things we'll discuss in today's session. Okay, so before that one, so we have a concept, big data. So do you have any idea what is a big data? Yeah, so big data is a huge amount of data. Huge amount of data means what? See, it is a huge amount of data, and the data is in you can say terabytes of data, and it's a petabytes, exabytes of data. So this amount of data, so how much terabytes? See, I'll show you one calculation. See here, see, this is a 1 byte is 8 bits. So here after that we'll have a kilobyte, MB, gigabyte. So till now, so we worked with gigabytes of data and terabytes of data. If you take the example Oracle, so in the Oracle we worked with gigabytes of data, 100 gigabytes of data, so multiple hundreds. So the data will be stored in the disks, and we are trying to retrieve the data from the disks, so that the data will be retrieved. So that means what? We processed till now gigabytes of data. And if you take the example of SAS Teradata, so we worked with terabytes of data. So this is 1 terabyte which takes approximately 1024 GBs. So this is the calculation. After that we have the petabytes of data, right? Then it's exabytes of data, and after that one zotabytes of data, and it's yottabytes of data. So it's hardly difficult to reach up to yottabytes of data. So there is a proverb like, so when we reach to 1 YB, so the world is going to end. So as of now, I'll tell you one thing. So we people in a Hadoop are in big data. We are working on terabytes of data, petabytes of data, and exabytes of data. Okay, so in big data, so we are working with huge amount of data. So I'll show you one thing. Suppose you take the example RDBMS, like RDBMS is like Oracle or MySQL or SQL Server, anything. So we are working on gigabytes of data. So the meaning of working on gigabytes of data means what? The data processing can be in gigabytes. So now, so when your business is going expansion, so you're having more business, and your business is spread into multiple continents or across the globe. So obviously you'll have more number of customers. You take the example like see Facebook, Amazon, eBay, like many companies. So they have crores of customers around the world. Now each customer have different types of descriptions and different types of requirements. Now if you store all the data of a customer in one place, that becomes huge amount of data, and we need a mechanism to organize, to process, to maintain that kind of data. So that is possible with big data. What I am saying is, so we'll have two types of data till now. It's a structured and unstructured data. Structured data means what? The data which is in one particular format. Suppose if you take Oracle RDBMS or any kind of RDBMS, the data is structured so that we are storing the data in the form of rows and columns, right? So if you want to retrieve the data from the data set, so based on the primary key, so we'll identify remaining tuples in that relation. So in case of if it is an unstructured data, so what happens in unstructured data? So there may be any particular keys. So there is no structure, right? So there is no primary key. So there is no one particular column, particular format is there. Even though there is a particular format is defined, but it's not mandatory to follow that particular format. So they are all considered as unstructured data. Suppose consider, I'll show you, suppose if you are storing the data in a plain text file. Yeah, this is an example of unstructured data. Suppose structured data means what? So the data which is in XML file. So XML data like so they're having one particular structure, so you have to store the data by following that structure semantics. So but coming into the big data, so there is no structure of the data, even though structure is defined, but it's not compulsory to follow the data. So that is, we'll have the data in a plain text file. Now I'll show you one example. Suppose consider I am writing a query, select count star from product underscore viewed, right? Suppose I wrote a query here, select count star from product underscore viewed, because I have a table, so from that one I want to count the total number of records. Now in the situation, suppose there are 1,000 records or lakhs of records, so it's okay, so you'll count the number of records. But here I'll show you one scenario. Suppose you are a user XYZ, visited Amazon.com 10 times today, right? The user ID is an XYZ, okay? He visited Amazon.com 10 times today. Now you're counting, like, so how many number of visitors viewed the page. Now how many number of times you have to consider this XYZ? So he is only the one user visited 10 times today. So now in this one, so when you are counting the total number of customers who viewed the product, so even though XYZ viewed the product 10 times or the 20 times, so it doesn't think issue. You have to consider whether XYZ viewed the product or not. So when you are counting the total number of users who visit the page, now even though XYZ occurrence is there in the multiple times, but when you are counting the number of users who visit the page, that comes into 1, right? Only the user 1 XYZ visited 10 times. Now when you are counting this kind of data, so now in a text data set in a file, so the XYZ username will be specified with multiple timestamps. So this particular time, hours, minutes and nanoseconds, and this particular date, so visited. Again in the same amount of time he is visited. Again in same amount of time he is visited, right? So the data can be represented with one username with multiple occurrences are there. So in that situation, so when you are counting the total number of users who visit the page, so even though he visited the 10 times, so you have to consider him as a one single one. So this is only possible when you maintain the data, that is when you are maintaining the data as a big data, and when we are working with Hadoop, it is possible. Now if you take RDBMS, right, so this is not possible. So because what, even one user ID with multiple timestamps, so when you are trying to retrieve the data, so it will retrieve XYZ records 10 times. So in this one, in this RDBMS, the XYZ can be visited 30 times today, so it will show you the count is 30. whereas big data will give you the total number of users visit the page, will give you the solution only one, right? So this is the difference between RDBMS and big data. And in the RDBMS only we work with the 1 gigabytes of data. In the big data we work with the terabytes of data, petabytes of data, exabytes of data. And the thing is what, it supports distributed, big data supports distributed data processing, right? So distributed data processing means what, the data can be distributed into multiple nodes. So from that one, so we'll work with the data, we'll work with multiple nodes parallelly to retrieve the data, right? So big data supports distributed data processing. And the database management system is a distributed databases, so we'll distribute the data into multiple locations, right? So here I'll tell you one main difference between RDBMS and big data Hadoop is, in case of RDBMS, so when you're counting the number of records, in that example, suppose if there are multiple occurrences are there, so it will list all the occurrences. And in case of big data, so we'll have a concept called map reduce. So in this one, so the mapper will map the data. After that one, so we'll have the reducer. So reducer reduce the data into a single entity and it will be displayed to the user. Okay, and finally, so in big data we are working on the data which is in a plain text file, right? So generally big data accepts the data from a text file, that is which is in .txt format, and we work with a CSV file, that is a comma separated values, like that is a .csv files. Okay, so generally in big data we work with a plain text file, that is a .txt, and so we have a .csv files. Because what I am saying is, suppose consider, so when you are working on Hadoop development, so you have to find out or you have to analyze the data. So what we will do with this in Hadoop is, we always will do only one thing. So our duty is to analyze the data. So being a Hadoop developer, your role is to analyze the data, right? So analyze the data. So the database huge amount of data, like the data is in TB, PB, EBs of data, right? So analyzing a small data in a rows and columns in right, so it will be easy, right? So simple, you'll write one column, one query based on the one primary key, so you'll write that query so to retrieve the records. But here the issue is different. So we analyze the data, but the data is, there is no structure is there, and the data, there is no particular keys are there, and the data which is a plain text file. So in the text file we are analyzing the data and we are retrieving the records. Suppose you have given find out what will be your next month sales. Right, so this is the one query you'll get. So what, find out what will be your next month sales. So now what you have to do, so you are a Hadoop developer, so your project manager assigned the job to find out, so what will be, like how much business you will generate in the next month. So in this one, what you will do now, so you'll have the data from the last 3 months, and based on the geographical situations and based on the users visited to your page, so based on the log files, based on the user browsing history, so you have to identify, and you have to approximately, you need to identify what will be your next month sales, right? So this is kind of analysis what generally we'll do in Hadoop. Okay, so I'll show you one presentation. Okay, So what is Hadoop? Yeah, Hadoop is an open source framework. So what is the open source framework is? So here the Hadoop is freely available. Even if you want to get how Hadoop is developed and what is the source code, and if you want to change the Hadoop, now Apache is providing open source for that one. Okay, so Hadoop is an open source framework, so designed to maintain huge amount of data. It works in parallel on large clusters. So what is a large clusters means what? So we'll have the multiple nodes. So a set of nodes together connected can be considered as a cluster. So right now the cloud era, so they are working with 4,000 clusters. Suppose consider, I'll show you one example. A business is having one cluster with 3 nodes. So when his business expansion is going on, and when his business is running well, so every day he's having more data to be generated. Suppose right now he's having the data of 10 TB, so he's and every month is generating 1 TB of data additionally. So now he's having the 3 nodes, and the next month becomes it is a 4 nodes, because he's generating more 1 TB of data for this week. So next week again the data grows for 1 TB. So now he's having 5 nodes. So similarly, so how your data is growing, so we have to keep adding one more node to your cluster. So in the terminology of Hadoop, so we'll say commissioning a node. Commissioning a node means what? Adding a node to the existing cluster. So initially we'll start a cluster with 10 nodes, right, with the 10 TB of data. And when your data grows to 1 TB extra, so we need one more disk, and that will be added to your existing cluster, right? That is, we call it as a commissioning the nodes. So now, so you have to keep adding on the nodes to your existing cluster, right? And Hadoop provides fault tolerance and HA. HA stands for high availability. So in the Hadoop, we'll have a file system SDFS that we'll discuss in later session. So based on that, it will provide you the fault tolerance and as well as high availability. So we'll see this HA and fault tolerance in the next session. So when we are discussing about SDFS. Okay, so as per the cloud era, they are saying that Apache Hadoop is an open source framework that supports data intensive distributed computing applications to process huge amount of data, and this is licensed under Apache v2 license. Right, in the Wikipedia you will find the definition of Hadoop is a Hadoop scales virtually without limits and handle any type of data, no matter how data is encoded or formatted, and the data, whether it can be a structured data or it can be an unstructured data. Okay, we'll see the differences between RDBMS versus big data. So in the RDBMS, see, the data size is in gigabytes. In big data, we are working on petabytes of data. So in RDBMS, see, we'll interactive and batch processing. In petabytes, in big data, so we'll have a batch processing. At one go, we'll run multiple requests. I will discuss how we'll do this one in the next session. So here it supports batch processing. So the main difference between RDBMS and big data is RDBMS says that, so once we write the data a number of times, so once you have created a data set, so you can insert the records whenever you want, and you can update the data, you can alter the data, you can retrieve the data, right? So this is possible in RDBMS. But when it is coming to the Hadoop big data, it is saying that, so we have to write the data once, and it allows you to retrieve the data many number of times. So every time you are modifying the data will not be, it is possible, but it will be little bit difficult issues here. So a big data says only one thing, so write the data once and you can read many number of times. As what I'll say one thing, suppose we write the data and we keep add the data at the end of the file instead of modifying the first record. Suppose considering the first row of a text file, we are having a customer name with another phone number with other details. So if you want to add new details of the same customer, so we'll append it at end of the file instead of modifying the data in the first column of the text file. So what we'll do, we'll add the same user with different values in end of the file. So that's what. So most of the times big data says that, so we write the data once. So the data will be sent to your plain text file and it will be given to you. Now we have to analyze the data. That means what? We will read the data many number of times, but updation and altering the data will be a difficult issue. Right? How we update the data, how we alter the data, that we'll see in the next session. So when we are discussing about Hive and Pig, so I'll show you what way we'll retrieve the data and what way we'll update, modify everything. Okay. As of now, you remember one thing. So big data is always says one thing: write once and read many number of times. So it's a static schema, and big data is a dynamic schema. Integrity is there is high, it's a low, right? It's a non-linear and linear scaling. Okay. So now see what is a big data. What is the main goal of this big data and Hadoop is, first the thing is what? We need to identify the behavior of a customer. We need to identify the requirements of a customer. So we need to identify what are the priorities of the customers. Based on that, you have to recommend some products. Or like I'll tell you one example. In Facebook, we'll have the likes, right? So now you're having a particular group of friends, and in this one, whatever they like, they will give you the recommendation. He liked that one, so you want to like this one, right? So the recommendations. Now in this one, how much data you'll generate in a hour? So how many users are there for the Facebook, and how many from that one, how many of them upload the images and posts and the data, how many likes they'll do. So there will be no limitations of that one. So there is no limitation that each user can only upload so this number of images a day, or so there is no maximum limit to upload the images in Facebook, right? So means what? Okay, fine, the users will do all those things, but in the back end, so you have to have a control on all the data. So you have to identify the your users, you have to identify their likes. Based on the likes, you have to fetch the ads in the right side column of your Facebook wall, right? Generally, see what we'll see in the right side. So we'll see the list of advertisements. So that advertisements are based on your likes, based on whatever your friends are liking. Suppose you like a car, so based on that you like, so the advertisements will be featured into the right side. So you just observe this one. You change your like in Facebook, then most of the times the advertisements in the right side is also going to change, right? Means what? So now you have to watch each customer what he is doing at present. I'll tell you one thing again. So what I need to do, being a business, right, being a customer of my business, I need to identify the particular user, and I need to identify him what he is doing in this site. So similarly, how many customers are there for my business? Now I need to identify all the customers who is doing what, right? So this is generally it's not possible with other frameworks. It is only the possible with big data. And what they will do now, so they will record entire browsing history from your logged into the page till you're signing out. So whatever the activities you're doing in that page will be recorded, right? After that one, based on your browsing history, I'll give you some recommendations. I'll tell you one example here. Suppose you open a website, Amazon.com or Groupon or anything, and you just try to buy a mobile, add it to the cart, and you just go for a little bit mobiles and add it to your watch list, and other mobiles, just watch it and keep it as like that one only. Don't add, just use the product. Now in the next day you'll get a mail of, so why so how you are like to buy, right? How much you are interested to buy the products, you are looking for any kinds of discounts on that product, or you are facing any difficulties while going to the payment of for the product. So these are the things. You will get a mail with a more number of recommendations, right? So based on your requirements, suppose consider you have observed all the mobiles which is having Android. So now the business will suggest you the mobiles which is on Android feature, right? And apart from that one, they will give you some more recommendations based on your requirements, or based on your requirements, or based on your search strategy. So this is what finally what we are doing here is, being a Hadoop developer, we are analyzing the data, we are analyzing a user, we are analyzing a customer, we are trying to analyze his behavior, his requirements, his priorities. Okay, so here it's a definition: big data is a data that is too large to process using traditional methods. Okay, here I wrote one line. So it is originated by web search companies uh, who had the problem of querying very large and distributed aggregations of loosely structured data. So initially Google developed MapReduce to support distributed computing and large data sets on computer clusters, right? So here I'll give you one example. Suppose it's a telecom based. You take one example of giving suggesting different plans. I'll give you one example. The customer XYZ is a customer of your telecom, and you're suggesting different types of plans to him. And a customer Y is there. He always uses roaming, is a traveler, he travels to different locations. Now if you want to suggest a plan for the Y, you have to suggest a plan based on the roaming, so that will be advantage to him. And instead of that one, the XYZ who stays in one location, you are giving the plans and you are offering him for the roaming. So here it will be no advantage for your plan, right? And if you the particular Y is there, so you won't go for the messages, but you are suggesting him with a different types of message plans. So he's not a regular user who will messages, who won't message SMS, right? You are giving him the plans of SMS, and for the user XYZ you are suggesting him the roaming. So now here you have to identify the user such a way that the user Y has to get the plans based on the SMS's message tariffs, and the user XYZ who prefers the roaming has to give the plans based on his roaming, right? So in this way you have to identify the customers. Okay, and finally big data can be which is in a petabytes or exabytes of data, and it's a millions and billions of people, and we have a billions and trillions of records are there, and our data is loosely structured, and often the data is distributed, and we have a flat schema. What is a schema? So the overall design, the overall structure can be known as a schema. It's a flat schema with a few complex interrelationships, and big data most of the times it's involved with the timestamps. So every transaction will be identified with a transaction ID with a particular timestamp. And I'll tell you one thing, the big data most of the times it is an incomplete data. The data which we are working is incomplete data. The data which we are working is inconsistent data. Big data most of the time the data we cannot say this is the data, right? We never say this is the data. So the data is always, it's an incomplete data, and most of the times the data is inconsistent. I mean to say that is not exact data. So in that one, the data which is not consistent, the data which is incomplete, now we are trying to analyze the data, right? So being a Hadoop developer, your role is to analyze the data which is incomplete, which is inaccurate. Okay, so so to work with the big data, so in the market, so we'll have the different frameworks. I'll show you, or you can work with the Teradata is a one lab framework. So you can work with big data, and SAP HANA is there. It's also the same kind to work with the big data, and Oracle's Exadata, and finally we have Apache Hadoop. So these are the things which are there in the market to work with the big data. So you can go with a Teradata, or you can go with SAP HANA, or you can go with the Oracle's Exadata and Apache Hadoop. So in this one, so the most preferable one is Apache Hadoop. What I'm saying is it's open source, it's a freely available, and I'll write. So the main difference between all these four is Hadoop can be integrated into any kind of infrastructure. Okay, so remember, Hadoop can be integrated into any kind of infrastructure, and I'll tell you one thing, Hadoop supports commodity hardware. Hadoop supports commodity hardware. Okay, so what is Hadoop can be integrated into any kind of infrastructure. So in this one, now if you want to move to the Hadoop, right, so there is no extra additional infrastructure to be needed. So in this your existing framework, so whatever the feature you are having in that one, so we can integrate Hadoop, right. So there is like, so if you want, I'll tell you one example. Suppose you are doing SAP HANA. In this one SAP HANA, if you want to use Hadoop, yes, it is possible. Even you can integrate Hadoop into SAP HANA framework. You can integrate Hadoop in a Teradata too, or whatever the architecture, whatever the framework you are having, right. So in this architecture, in that framework, you can integrate to Hadoop. And Hadoop supports any kind of hardware. So the reusable, the existing hardware is a commodity hardware. So the commodity hardware is a low-end machines or medium level machines. Even you no need to buy a high-end storage clusters, right? You can use a simple machine, a simple hardware or the simple machines with a reusable or the existing hardware, existing infrastructure, whatever you are having, in that one you can use Hadoop, right? So you no need to buy any kind of additional hardware. So but when it's coming to SAP HANA, you need to buy the SAP HANA storage servers, which a single node costs you up to $300,000. So you need to invest more on this one, SAP HANA, Oracle, Exadata, Teradata. But Hadoop, no need to buy any kind of extra hardware. So okay, so the existing hardware can be existing infrastructure. So in that one you can use Hadoop, and Hadoop supports commodity hardware. Any questions? Okay, so Hadoop supports commodity hardware, and apart from that one, so no need to buy the license. Apache, it's a open source. Okay, open source means what? It's freely available. You just download this Hadoop from the apache.com and you can start working on Hadoop, right? So here you have to buy the Teradata. Suppose in case of Teradata, see, you have to buy a separate application engine for this one. Okay, you need and you need to have a separate hardware, and you have to buy the license, and you have to pay for the support, right. Both SAP HANA to same, you need to have a separate application engine, you need to have a separate hardware, you have to buy the license for SAP HANA, and you have to pay for the support. The same thing for the Oracle Exadata, right. You need to have a separate application engine, you need to have an hardware, a license, and you have to pay for the support. But when it is coming to the Apache Hadoop, so no separate application engine is needed. So in your existing infrastructure, in Java, if you're having in that one, so in existing framework you can run Apache Hadoop. So there is no extra hardware is required. So no need to pay for the license, and the support, the cost for the support is very much less comparing to these three things. So we have to pay for the support for the vendors. So I'll show you whom you have to pay for the support. So Hadoop is available with different vendors. Hadoop distributors. I'll show you one presentation. Okay, so Hadoop is available with Apache Hadoop, and it's a Cloudera Hadoop, Hortonworks Hadoop, Mapper Hadoop, Intel Hadoop, right? So these are the Hadoop distributors. So Hadoop distribution is presently doing by Cloudera, Hortonworks, Mapper, Intel. So if you want to use Hadoop, if you want to work with Hadoop, either you can work with Apache Hadoop, or you can go for a Cloudera Hadoop, or you can go for Hortonworks, or you can go for a Mapper Hadoop or Intel Hadoop, right? So the Cloudera or the Hortonworks is there. So this is a link which is in the Cloudera website, and this is Hortonworks, right? So Mapper is giving 3 types of versions of Hadoop, that is M7, M5, M3, and it's an Intel Hadoop. Okay, so they are the distributors. Even Red Hat is trying have its own Hadoop, which started Red Hat started 2 months back, starting supporting on Hadoop. Okay, and yeah, so Hadoop can so as per the calculations till 2015, so there are every business needs Hadoop. Okay, so now almost see we'll see the difference in the last year and this year. So how Hadoop is spreading into the businesses, spreading into multiple businesses, because the thing is what, it is not possible to evaluate the data with a traditional method. So everyone present required Hadoop. So till 2015, so there are n number of positions, so thousands of positions are there available to work with Hadoop. So every business has to implement Hadoop in their framework. Even I am saying that, so no need to go for a separate infrastructure, right? So what the business is doing, so they'll add a node, and in that one they'll start working on Hadoop. So every business will have Hadoop in the coming days. So till 2015 you will find Hadoop everywhere. Any questions? Okay, I'll show you the content. So in our training, so I'll provide you the training on. So, hello. So these are the topics we are going to discuss in entire session. So we'll have in the chapter 1, I'll show you the introduction of Hadoop. So like, see what is a big data, what is Hadoop, Hadoop ecosystems. So what is the SAP HANA versus Teradata, and the case studies, how Hadoop and Hive can be used in Facebook. So this is chapter 1. And in the chapter 2, so we are going to discuss about Hadoop distributed file system, SDFS. So what is SDFS design, Hadoop file systems, right? How we'll do the serialization in Hadoop, right? How we read the data from a Java program, or how we read the data from plain text file. So those things we'll see in the chapter 2. And in the chapter 3 we'll
Yes.
hello, any questions? Okay, so in chapter 3 we'll have a Hadoop administration. So I'll show you the what are the clusters and how to set up Hadoop cluster and how to install Hadoop in a production, and I'll give you the step by steps for a multi-node installation, and how to configure Hadoop post configuration steps, and we'll see the name node, what is a data node, direct structure. Hello. Yeah, Farhan. Hello. Yeah, Farhan, you have any question? No. Okay, so now in the session we'll see the Hadoop user commands, and I'll show you Hadoop administrative commands and how to monitor the Hadoop cluster and how to benchmark Hadoop cluster. Those things we'll see in the chapter 2. So it's a part of administration. I'll show you what is a DFS admin, so how to admin the Hadoop cluster. So those things we'll have in the chapter 3. So both the chapter 2 and chapter 3 will give you a concept like how to administer Hadoop cluster, so Hadoop administration. And in the chapter 4 we'll have the map reduce. Okay, I'll show you what is a map reduce. So regarding the map reduce we'll have in the chapter 4. So and in the chapter 5 we are going to discuss about complete a Hive. Okay, Hive concepts, Hive programming, everything we'll discuss in Hive in the chapter 4. Chapter 5, in chapter 6 we'll have the pig. Okay, so pig, it's a programming. Hive and pig are the programming. Hive is like SQL like programming. Pig is like script language like programming. It's a script based programming. It's a pig. So chapter 6 we'll have, and in the chapter 7 I'll discuss what is a zookeeper, how to coordinate all the components in Hadoop, that we'll see in chapter 7 zookeeper. And in the chapter 8 we'll have a scoop. So scoop is a tool which is used to how to import and export the data between Hadoop SDFS to RDBMS. So that we'll see in scoop in the chapter 8. And after that I'll give you the introduction, what is HBase, what is Uzi, what is Vertica, what is a Manhot, so what are the Cassandra, what is cascading, so what is MongoDB. So I'll give you the descriptions about all the components whatever we have in Hadoop. Those things we'll discuss in chapter 9. So these are our course contents. See, I'll show you one thing. Suppose in Hadoop, so what generally we'll do the data processing. Okay, so the data processing can be done using MapReduce and Hive and pig, using pig. So MapReduce is a Java based programming, so it's entirely Java code. So we'll write the Java programs to process the data. Suppose if you don't know the MapReduce, then we'll write the queries on Hive. So Hive is like SQL like programming. Like see, we'll have a create table like syntaxes in Hive. Okay, so pig is like pig is a data flow language. Okay, which is like script language. Okay, so suppose I want to print the values of the variable, suppose display records. Then I'll write a statement like dump. Okay, dump display underscore records, so it will display the values in the table or in the schema display records. So like programming will have in peak. So MapReduce is, it's a completely Java code, and Hive is like SQL programming. Peak is like a script language kind of programming. So we'll write the programs on Hive, peak, and MapReduce to process the data. Okay, see, suppose consider Hadoop is giving such a kind of flexibility. Even if you want to write the code in C, comma C++, you can write the code, so there is no issues like so it's, you are not supposed to write the program in C++. You can write the code in C++, or you can write the code in Java, or you can, if you are good programming skills in Python, so you can write the code in Python, or you are a .NET programmer and you can write the .NET code too. So here what will have, even that you write code in C++, Java, Python, .NET. So in the MapReduce we'll have the two classes, that is a mapper class and reducer class. Now what it will do, it will read the code from C++ or Java or Python or .NET and converts that code into native of Hadoop. Okay, so even you write a code in any languages, any of these languages, what happen now in the MapReduce, in MapReducer, mapper and reducer will have, so this mapper and reducer will read the code from so these languages and convert it into the native of Hadoop. That is again in so Java or more Java or MapReduce. Okay, so suppose a user you don't know C++, you don't know Java, Python, .NET, and you are new for the programming. Now Hadoop is providing Hive comma peak to write the programs and MapReduce. Okay, so you can write the code in any of these languages. So for the .NET, Hadoop is providing a component that is SD Insight. Okay, so using this component SD Insight, we can write the .NET code for the Hadoop clusters, right? So you don't know any of these programming languages, or you're new to the program. Now learn Hive comma pick comma MapReduce to analyze the data. So these are the programmings we'll have in Hadoop: Hive, pick, MapReduce. Okay. Okay, so fine, I'm ending my session here. So in tomorrow's session, so we'll discuss Hadoop ecosystems, and we'll see what is SDFS, and we'll see Hadoop file system, right? I'll show you the Hadoop environment. Okay, so these things I will see in next session. Fine, thank you. So any questions you have, Abhishek and Jigar? Hello?
Nope, we're good.
Yeah, okay. Yeah, fine, Abhishek. So I'm ending my session today. Okay, fine. So we'll see, meet you in the next session. Fine, thank you.
The organizer